Here is every single exponents concept that you need to know in order to prepare for your SAT math section. So we have exponents laws, fractional exponents, negative exponents, and exponential equations. So first we're going to look at every single law of exponent. There are 8 laws of exponents. So let's get started. And in this video I'm also going to take the different types of questions which are asked on exponents. So first up we have the multiplication law, which is, so if you see two powers are multiplied, for example a raised to m, this is multiplied by a raised to n. In this case we add the exponent, so just make sure that the bases are same. So here the base is a, and exponent is m and n. So these exponents will be added only when the bases are same. So this is equal to a raised to m plus n. Then we have a similar case for division. So if you have a raised to m divided by a raised to n, in this case your exponents will be subtracted. So this will be equivalent to a raised to m minus n. Then we have power of a power rule. So if you have a raised to m, that's a power, and this is raised to n. So in this case your exponents get multiplied. So you get a raised to m times n. Then next we have, you could say that distribution of exponents. So for example, if you have a times b, and this entire a times b, the product of a and b, is raised to exponent m. In this case the exponent m gets distributed to each of the bases. So this m will be distributed to a and it will be distributed to b. So we get a raised to m times b raised to m. Same thing will happen in case of division. If you have a divided by b and this whole thing raised to exponent m, so again it will be distributed, so you get a raised to m over b raised to m. Then what happens if you have exponent 0? So anything raised to 0, that is nothing but just 1. Next we have negative exponents. So what do you do if you have a raised to negative m? So whenever you see a negative exponent, always try to make that exponent positive. And how you can make an exponent positive is by taking the reciprocal of the base. So this is the base, right? This is the base. So we are going to take the reciprocal of a. So that is nothing but 1 over a. And this whole thing raised to exponent m. When you take the reciprocal of the base, the exponent becomes positive. Now there can be a corollary of this law. You could also have something like a over b raised to negative m. So your base now is a over b. So the reciprocal of a over b is b over a, and this whole thing raised to m. Now these are all the exponent laws that you need to know in order to solve any kind of exponents problem. The SAT loves to test you on this one, negative exponents, and this one, also this one. Okay, now so we have covered the exponents laws, fractional exponents. Okay, we have not covered fractional exponents, so let's do that. So we have covered exponents laws, we have covered negative exponents. Next is fractional exponents, and then exponential equations. After that we'll do a couple of questions. So fractional exponents are nothing but radicals. You might have heard of this term called radical. For example, if you have a raised to 1 over 2. So 1 over 2 is a fractional exponent. So this is a very basic 1 over 2 is nothing but this is very basic exponent. This is very basic radical. So you get square root of a. Then if you have a raised to 1 over 3, this is nothing but cubic root of a. Okay, so on and so forth. So what happens in when you see a fractional exponent, what happens is the numerator of that fraction becomes the exponent of the base, and the denominator of the fraction becomes the radical part. Okay, so now let's say you have a raised to 4 over 5. So this can be written as a raised to 4 and then you take its fifth root. So these are your radicals. Then finally we have exponential equations. Now SAT loves testing you on the fourth concept, which is exponential equations. It is also about matching the bases. I'm going to write it here, matching the bases. Let's say we have a problem like this. 512 is equal to 2 raised to x times 2 raised to x, or let's do 2 raised to 2 raised to x. We have a problem like this and we have to find out the value of x. This is a very basic exponential equation problem. Exponential equation means that your the variable that you're trying to solve will be in the exponent. So here the variable is x and that is in the exponent, and we need to find out the value of x. Okay, so in this case what we will try to do always is we will try to make the bases same. Now you'll say that 512 is not in the form of exponents, so you will have to make 512 in the form of exponent. Now on the right hand side we see the base is 2, right? The base is 2. So on the left hand side as well we need to convert 512 in the form of a power which has base 2. Now I know that 512 is actually the cube of 8. 8 cube is 512. So I'm going to write 512 as 8 raised to 3. This is equal to 2 raised to x. Still the bases are not same, right? On the right hand side the base is 2 and on the left hand side the base is 8. Still the bases are not same. Now I also know that 8 is cube of 2. So 8 can be written as 2 raised to 3, and this 3 we already have, this guy. So now I can say that the bases are same, 2, 2. Now we'll apply the power of power rule. So this is 2 raised to 3 times 3 equals 2 raised to x. And now you can see that the bases are same. On the left hand side you have base 2, on the right hand side as well you have base 2. Now once you have the bases same, you can equate the exponents. Now you can equate the exponents. So your exponents 3 times 3 and x, these become equal. So 3 times 3 is 9, 9 is equal to x. So the value of x is 9. So this is all about exponential equations. Of course the questions are not going to be this simple, but this was about exponential equations. So remember that whenever you see a variable in the exponent, try to make the bases same on both the sides. Alright, so now we are going to do some questions. We are going to do some difficult questions now. Alright, so first we have x raised to 3. We have x raised to 3, negative y raised to 2, z raised to negative 2, whole over x raised to negative 2, y raised to 3 times z. This is all equal to x raised to m over y raised to n times z raised to p. We have to find out the value of m plus n plus p. M plus n plus p. Whoa! Now the thing is, what would you do if you get this question? Oops, why this is percentages? Let me remove this percentages. This is the next topic that I'm gonna do in the concept summary playlist. Anyway, what will you do? Let me know in the comments. Pause this video, try to solve this by yourself, and first let me know what answer are you getting. Okay, I hope you solved this question. Now, in order to find out the value of m plus n plus p, first of all we see that m is here, n is here, p is here. So if I get everything on the left hand side in this format, if I'm able to get something like this, x over y times z, and they have something here, x has some exponent, y has some exponent, and z has some exponent. If I am able to get this expression in this form, then obviously I'll get the values of m, n, and p, right? Now in this expression, in the numerator I only have x, and in the denominator I have y and z. So all the x terms should be in the numerator, and all the y and z variables should be in the denominator. So that's what we're going to try to do. So I want to bring all the x variables in the numerator. I see there is one x term in the denominator, and this one has negative exponent. It is x raised to negative 2. Okay, so if I bring this variable x raised to negative 2 in the numerator, the exponent will become positive, because hey, x raised to negative 2 can be written as 1 over x raised to 2, and this is a denominator, so if you take its reciprocal it will become x square and it will go in the numerator. So I'm gonna get x raised to 3 times x square. So we are done with the x terms, and now we want all the y variables in the denominator. So we have negative y square. Now negative y square, this is what? This is negative y times negative y, right? So this is y square. But this is in the numerator, we want to bring it in the denominator. So if you bring it in the denominator, the exponent will become negative. So this becomes y raised to negative 2 times y raised to 3. Y raised to 3 we already have. Then we also want to bring all the z variables in the denominator. So right now we have z raised to negative 2. If it comes in the denominator, this will become positive. So we get, so we get z raised to 2 and 1 z we already have. Now all we need to do is just apply the multiplication law, and we'll have the answer in next step. So this is x raised to 3 plus 2, that is 5. Then we have y raised to negative 2 plus 3 is 1. Then we have z raised to 2 plus 1 is 3. So that means m is 5, n is 1, and p is 3. So we get m plus n plus p as 5 plus 1 is 6, 6 plus 3 is 9. So 9 is the answer. Okay, let's do one more problem. Now, it has been given that 2 raised to x is equal to 5, and we have to find out the value of 2 raised to x plus 2 raised to 2x plus 2 raised to 3x. We need to find out the value of this expression, and we only know the value of 2 raised to x. So I am thinking we know the value of 2 raised to x, but what about 2 raised to 2x and 2 raised to 3x? Now here we need to apply the opposite of power of a power rule. You remember the power of a power rule? It says that if you have a raised to m, this is raised to n, so we get a raised to m times n. And we need to do its opposite. So in the 2 raised to 2x term, I can write it as 2 raised to 2 whole raised to x. This can be written as 2 raised to 3 whole raised to x. But the thing is, I know the value of 2 raised to x, so I'm going to change the order of the exponents, because multiplication is commutative. It doesn't matter if you change the order of the exponents. So I'm going to write it as 2 raised to x whole square and 2 raised to x whole cube. And the first term was 2 raised to x. And now I know the value of 2 raised to x is 5. So I'm going to substitute the values. So we get 5 plus 2 raised to x is 5 whole square. 2 raised to x is 5 whole cube. So 5 is 5. 5 square is 25. 5 cube is 125. 5 plus 25 is 30. 30 plus 125, it's 155. Okay, let's do one more problem, and that will be the last problem. Okay, we have 3 raised to x plus 3 raised to x plus 3 raised to x. All of this is multiplied by 3 raised to x, and we have to find out which of the following is equivalent to the expression shown above. We have 4 options. We have 3 raised to 4x, we have 3 raised to 3x square, we have 3 raised to 1 plus 3x, and finally we have none of the above. None of the above is for those students who are not able to get any correct answer. Okay, let's see what we have here. So we have 3 raised to x plus 3 raised to x plus 3 raised to x. Most of the students in this question, what mistake they're gonna do? Most of the students are gonna add the exponents. They will say, okay, let me add x, x, and x. So they'll do 3 raised to x plus x plus x, and they'll get 3 raised to 3x, and you have 3 raised to x. This is the mistake that most of the students will do, and then they will give the answer as 3 raised to 3x plus x, 3 raised to 4x, and they will select option A, which is wrong. And you see that SAT test makers will always give you the incorrect option as option A, because they know exactly what mistakes students are gonna do. Okay, so don't do this. You cannot add the exponents here because these powers are getting added. These are, you know, this is plus, this is addition. You could have added the exponents if this had been multiplication. Then this answer would have been correct. But no, this is not multiplication, this is addition. So what do we do over here? So first thing you see that this 3 raised to x, 3 raised to x, 3 raised to x, it's the same thing, right? So the same thing is getting added 3 times. So what happens? This is the case of repeated addition, right? This is repeated addition. So thing is getting added multiple times. So this is This gets multiplied by 3 because this is getting added 3 times. So 3, let me change the color. This is nothing but 3 times 3 raised to x, because 3 raised to x is getting added to itself 3 times. Okay, now 3 just has the exponent 1, right? So I can apply the multiplication law of exponents to get 3 raised to x plus 1, and then this is multiplied by 3 raised to x. And now again I can apply the multiplication law to get x plus 1 plus x. So I get 3 raised to 2x plus 1. Well, this is not present in any of the options, so none of the above is correct. If this had been 2x, if this option had been 3 raised to 1 plus 2x, then this would have been correct. But for this one, none of the above, option D is correct.